In this question, we are given some information about the average annual cost of homeowners insurance, and we're told that the distribution of cost is normally distributed, and we're given the standard deviation. So this information, the mean and the standard deviation given in the first paragraph, is telling us about the underlying X distribution. In part A, we're asked to find the probability that a single randomly selected consumer spends more than $14.31 on homeowners insurance. So here we're asked the probability that X is greater than $1,431, and that is a probability related to the underlying X distribution. So we're looking for this area to the right of the distribution value 1431. So with that in mind, let's define our normal distribution with the parameters that were given. And we are looking for, as we saw, a right-sided probability. That's what a greater than probability is, represented by the area to the right of the value. And we are computing the area. The area is what we want because the area represents the probability. So we'll put in the value that is the lower bound of the area, 1431, having defined my X distribution, and we get 0.053. I want to give 4 decimal places though, so I'm going to pop that down. If it's helpful, I can click here to just drop this into a separate line, and then I can see all the decimal places that I need to put in my answer to 4 decimal places. In part B, we're asked to find the boundaries of the middle 50% of homeowner insurance policies cost. So the question says the cost of the middle 50% falls between what values? So translating what we're asked here into a probability, we are looking for X1 and X2 values that are centered about the mean. And we know that because it says the middle 50%. We want to find the lower and upper boundary centered about the distribution mean, so that the area in the middle between those boundaries is exactly 50% of the distribution. So we're looking for the X1 and X2 values. So back to our normal distribution, I'm going to use the same distribution we already defined, but I'm going to make a new instance of it so that I don't lose the work I did on the first part. Now, this is a between probability, so that means it's an inner region. We want a region between 2 values. That's an inner region. And we're not looking for the area. We know the area that we want to have centered in the middle of the distribution. We're looking for the bounds. So I'm going to change the compute to bounds, and I'm going to put 0.5 as my area, and then the bounds are given here. We're rounding to the nearest dollar, so the rounding that I'm shown in Desmos will be fine here, and I can enter my lower and upper bound. In part C, we're asked a question about a random sample of 65 consumers, and we want the probability that the sample average is between the values 1,285 and 1,319. So we have here a sample with a sample size of n equals 65. The probability we're looking for is a between probability, but it's not about X, it's about X bar. So we can state the probability in probability notation, but the value we're looking for is a probability related to X bar. And so the distribution is no longer the X distribution, it's the X bar distribution. Well, we know that the X bar distribution is distributed normally. It has a mean equal to the mean of the underlying distribution. So that's 1297. And it has a standard deviation equal to the standard deviation of the underlying distribution divided by the square root of n. So when we define our distribution in Desmos, those are the values we're going to use for the mean and standard deviation. And then we're looking for the probability, which is equal to this area between those values in the sampling distribution. So again, over here in Desmos, I'm just gonna duplicate the line I had before, and all I have to change here is the standard deviation of the distribution, because now I want the standard error of the sampling distribution as my standard deviation. So this is related to the distribution we used in parts A and B. In A and B, we were using the underlying X distribution. Now we're using the sampling distribution. I again want an inner area, and I'm going to be computing area this time, not the bounds like we did in part B, because here I'm asked for a probability. So I'm going to put in the bounds that we were given, 1285 to 1319, and that gives me over here then returns my probability value. Again, I want 4 decimal places, so I can pop that value down into a line so that I can see all the decimal places and then put in my answer.